Let's build a personal habit tracker with Java. In this video, I'm going to show you how to create a simple tool that helps you stay consistent every day. Before we dive into the code, here's what a habit tracker looks like on paper. A list of habits and a grid where you mark your progress over time. It's a straightforward idea and we're going to bring it to life in Java. And before we get to the code, here's a cute rabbit because rabbit rhymes with habit and we're making a habit tracker. Let's get started. This is the class diagram for our habit tracker and it shows us what we're gonna build in this project. So we'll start off with the app class. This is the entry point of the program. Its only job is to start the application by creating and launching the console UI. And here we have the console UI. This class handles all user interaction through the console. It depends on a habit service to perform the actual operation. When a start method is called, it presents options, reads input, and delegates actions like creating or listing habits to the service. After console UI, we have to take a look at the habit service we're gonna code. This is a core business logic layer. It receives requests from the UI and coordinates habit management. It uses a habit repository to access stored data, create habit, builds a new habit from a habit create request, list habits, returns all stored habits, increment a streak, updates the streak count for a habit, and delete habit removes a habit by its ID. Habit repository interface defines the required data access operations. It abstracts how habits are stored, so the service layer doesn't care about the actual storage mechanism. It declares methods for saving, finding, listing, and deleting habits. In-memory habit repository is an in-memory implementation of the habit repository. It uses a map of integer and habit to store habits. It auto-assigns IDs using an internal counter, and it provides concrete versions of all repository methods, making it useful for simple applications or testing. The habit class is the model representing a single habit. It stores fields like ID, name, description, creation date, and streak count. The withStreak method returns a new habit object with an updated streak value, supporting an immutable style of updating. And habit create request is a simple data carrier used when creating a new habit. It contains only the name and description needed for the initial creation process. Now it's time to talk about the relationships between these classes. Well, first of all, app creates console UI. Console UI uses habit service to execute actions. Habit service depends on a habit repository for storage operations, and in-memory habit repository implements the habit repository interface. Habit service creates and updates objects and uses habit create requests for input validation and construction. Now it's time to start coding from scratch. First, I want to build the structure for our habit tracker. So I'm going to create a package. I'm going to call it habit tracker. Then inside the habit tracker, I'm going to have another set of packages. First of all, I'm going to create the package for our UI. It's going to be a console UI. And then I'm going to create a package for my service layer. And after that, we're going to have one for repository. Repository. And then one for model. And another one for DTO. And if you see here, we have a class called app. So I'm gonna create that class too. We start off by the top of the class diagram. So Java class, let's call it app. And inside app, I'm going to write my main method. So inside my main method, I tell them what I want to do. So let's create the app. Yes, VM. So now it's time for our habit service. And it's going to be new habit service. And inside that new habit service, we're gonna use the in-memory habit repository. That's going to be it. And down there, console UI, I'm gonna have my UI, and inside that we have new console UI, and inside the console UI we're gonna pass down the service. We're gonna code this all the way in, don't be nervous. So this is not an equals, yeah, this is an equal, and what we're missing is we're gonna call the start method on the UI, and yeah, that's about it. So here's the full code. Let me show you. Here's the bit we coded right now. This is the app, this is the entry point of our program. Now I believe it is best if we start with coding our model. So we're gonna create a class. We're going to name it habit, and inside the habit is going to be a final class. I'll tell you what I'm doing right now at the end of the video, so don't worry and follow along with me. So private final int id, and then we have private final string name, description, and for the date created when we created that new habit. So we're gonna have private final local date, and we're gonna name it date created. The caps lock is on local date created, and then we have the private final int string. And for these properties, we're going to need a constructor. The constructor needs to have all these properties in it. So let's create the constructor, and at the end we're going to add the new method we talked about. The method we talked about is the with a string, but before that let me just insert the getters we're going to need. These all return the properties. Get ID returns ID, get name returns name, and now it's time for creating the method with a string. So it's going to be public, it's going to return a habit, and it's going to be named with string, and it's gonna take in a new string. Yeah, the new string is not new string, new string, and new string, and we create it. And here we just return a new habit with ID, name, description, date created, and new string. Now it's time to override our equals and hash code. So I'm going to use override annotation here, and I'm gonna have public boolean equals. It takes in an object, and inside it I'm going to see if is not an instance of habit. So if the object we receive is not an instance of habit, we're going to return false. And then we come down here, we have a habit called I'm not going to call it H, I'm going to call it other, and then I'm going to return if the ID of this current object is equals to the other object we received, then they're equals. And now it's time to override the hash code here. When we override equals, we have to override hash code too. So inside hash code, I'm just going to return objects dot hash the ID. I'm going to hash the ID, and with that we're done with our model. Remember the habit create request we talked about in our diagram? So we're going to have a habit create request, the request the user is going to give us, and it is only going to have, let's make this one final 2, and we're going to have only the name and the description. These are the only things that we're gonna get from the user. So let's have private string, private final string name, and then we'll have the description. And then, like always, we're going to have the constructor and the getters. So the getters for string and description. Yeah, and we're all set. Now we'll need the code for a repository interface. So I'm going to call it habit repository, and inside it's going to be an interface. And inside our habit repository, we're going to have a method called that returns habit and is called save. Takes in a habit and saves it to our memory. So let's just import the habit. It's the same habit we coded in the model. And then we're going to have optional of habit and find by ID. So our ID is not long, it's an int. And then we're going to have a list of habits and have the find all method. And then we have void delete by ID. And here we're done with our interface. Now that we have our habit repository, let's have the implementation too. So we're going to have a class. We're going to call it in memory habit repository. And this habit repository is going to implement the habit repository we had. So we're going to implement the methods here. We have the save, find by ID, find all, and delete by ID. First of all, what we need is that we need a map to store our habits. So we need a storage. So we have private final map of an integer for the IDs and the habit itself. And we're going to call it storage. It's going to be a new hash map. Good. And then all we have to do is import the map here, and we have a private integer called ID counter, and we're going to set it to 1. Now it's time to implement the save logic. Here we don't have any logic yet, but that's going to change right about now. We have a habit, the habit we want to store, and we're going to set it to the habit we received in the save method. So if we have an if, so if habit that get ID, caps like if habit that get ID equals 0, then go and set it to store to a new habit and pass in the ID counter plus plus habit that get name, habit that get description, and habit that get date created, and lastly we have habit that get strict. So this is going to be the habit we create. Let's just put that here. Let's just from here. Yeah, I think it's better so you can see everything. So what we did is we have the name, we have the counter, we have the name, we have the description, and we have 2. So yeah, and we need the semicolon here. We get out of that if block, and down there we have storage that put to store that get ID and to store. So the ID and the habit we want to store in our storage, and then we return to a store we just created. Now we have all the code to save our habit into our storage, which is a map of integer and habits. There are 3 more methods to implement. So we have the find by ID one. What we're going to do is that we're going to return optional of nullable storage.getID. So we're going to get that from our in-memory storage. And the next one is find all. What we're going to do is we're going to return an array list of storage values, which is perfect. And for the delete by ID one, we're going to have just storage.remove by ID. And with that, our in-memory habit repository is complete. Now that we're done with our repository, let's go to our service layer and have a Java class, call it habit service. And inside the service, we're always going to need our repository. So private habit repository, and the constructor is always necessary. And down here, we're going to have to implement a few methods. First of all, we have public habit create habit method, which takes in a habit and creates it. The second one is going to be list habits. So public list of habits, but what we're going to do is we have the list of habits. We're going to call it let's call it list habits. And then the next method we're going to need is public. It's going to return a habit and increment strict. So we don't need the habit itself, the ID is enough. So int ID. And the last one is going to be a public void for deleting the habit by ID. So now we have to implement these 4 methods in our service layer. Let's implement the create habit one. So we have a habit, we create a habit, we call it new habit, and inside it we're going to have a new habit. But what we're gonna pass down is important, because we come down, we pass 0 as an ID, then we have habit dot get name, and then habit dot. So here's a little mistake I made here. We're not getting habit as create habit. We're receiving a habit create request. So this is going to be habit create request. I'm keeping it here because it's important, you know, that these stuff happen while coding and that you have to keep an eye for detail. So the habit is going to have a description, get the description, then come down and have local date now for the create date we need, and 0 for strict because you're just creating the habit right now. And then we're going to return habit repository that save the new habit. Next up, we have to list the habits. So here all we've got to do is have the habit repository and call the find all method on it. And then for the increment strict, it's a little bit more complicated than the other ones. So we're going to have habits and call it habit here. And then we're going to find the habit by ID. And if not, if we don't have or we don't find it, we're going to have or else throw. And in our or else throw, we're going to write a little something new illegal argument exception, and we're going to tell it habit not found. So it's great like that. If we do not find the habit by the ID that we were given, we're going to say that habit was not found. And then if it was found, we're going to update it, update the habit, and have not this one. Updated habit is going to be habit dot with a streak, the with a streak on the model we coded earlier, and we're going to increase it by 1. Then we're going to come down and return repository.save the updated habit. And for our last method, which is delete the habit by ID, all we're gonna do is have the repository that delete by ID and delete it by ID. Now we're done with the service layer here. Now it's the perfect time to code our console UI. So I'm gonna create the Java class. I'm gonna call it console UI. And here I'm going to have my service, and so we're gonna have private final habit service, and then as always I'm going to have my constructor here. And now what I'm gonna do is that I'm gonna implement the start method we talked about in our diagram. So public void start, and in my start method I'm gonna have a scanner because I'm interacting with a user. I need values they enter. So this is going to be my scanner, and I want the code to keep working, so I'm going to have a while with always true, and I'm gonna show some stuff to my user. So I'm gonna tell them that this is a habit tracker. I'm going to come down and I'm gonna show them the options they have. So the first option is going to be to create habit, and the second option is going to be show habits, or let's call it list habits, and the third one is going to be to increment the streak. Perfect. And then the fourth one is going to be about deleting the habit. So s out, fourth one, delete habit. Let's just capitalize this one too. And down we have our fifth option, which is exiting. And now we're going to ask the user to enter their choice, and we come down and we collect their choice. So it's going to be int choice equals integer dot parse int and scanner dot next line. And now it's time for our switch case. So in our switch case we have a case 1. Whatever the case 1 is going to be, it's creating a habit. So first up, I'm going to ask for the name of the habit they want to start. So they're going to have a habit of what, and then I'm gonna collect their choice. So it's going to be scanner.next line. After that, I'm going to ask for description, and they're gonna give me the description. And after that, I'm going to create a habit for them. So habit is going to be this one, and we have service, our service dot create habit, and inside the create habit I'm going to do that with a habit create request, which takes the name and the description. And when I'm done, I'm going to tell the user that the habit was created. And now it's time for case 2. For case 2, I'm going to list the habits. So I'm going to need a for loop, and inside that for loop I'm having habits. I'm going to call it habit, and the habit is going to be from service that list habits. And now we enter the for loop, and inside the for loop, all I'm going to do is have out habit dot id get the id, and after I get the id, I'm going to show id here, space, and I'm going to show the name here. And after I show the name, I'm going to also show the streak, how long they've been following that habit. So streak is going to be equals, and then I'm going to have habit.get a streak. It's as good as that. Let's just take it one down. Yeah, I think we're good to go. And now it's time for case 3. So inside our case 3, we're going to ask for the habit ID. Out is going to be habit ID, and the user is going to enter it, so we have to collect it. So integer parse it scanner, that next line. After that, we have to update our habits. So I'm gonna call that updated, and inside it I'm going to call my habit service and call increment streak with that exact habit ID we received, and I'm gonna tell them that habits got updated to plus updated that get streak. And now we're done with case 3, and now it's time for case 4 for deleting an item and a habit from our list. So it's going to take in a habit ID they want to delete and come down here, collect that habit ID, and then from our service we're going to call delete habit and tell them that the habits got deleted. And after that, last option is case 5 in case they want to skip. So I'm going to show that let's tell them goodbye, bye, and then simply just return. Great. And now for my default option, all I'm gonna do is tell them that there's an invalid choice. What they entered is not either 1, 2, 3, 4, or 5. They entered something completely irrelevant. Now we're done with our console. I'm going to go back to our to my app class. We have the habit service here. We have to import it. We have our in-memory habit repository. So to start the app, we create the service and we pass it to our console UI. So the console UI is like this here. Great. And then on UI, I'm going to call start like the method I implemented just right now. Now that I'm taking a look at my console UI, I see that I never used this habit here. So let's just get the ID to the console so the user sees what habit got created with what ID. And let's go back to my app. The app here is the starting point of my program. So I'm going to run my code. And here I have the habit tracker. So I'm going to create a habit. My choice is 1. The name is working out. And I have to work out every other day, and hits. See what happened? So all I had to get was habit created. This thing here should not be like this, you know. I should have gotten the list here so I can make a choice again. So why didn't I get what I wanted? Let's look at my code. So there's nothing here to see in the app class. The problem lies here. The problem is that there's no break with my cases. See, when let's just close this one. When my case 1 runs, there's no break, so it falls to case 2. And after case 2 finishes, it's going to fall to case 3. And it just goes on and on. So how I'm going to fix it is that I'm going to use the arrow style switch case, so that I don't need to manually write break for each case, and it's going to work perfectly, and we're going to get rid of the problem we just encountered. So I think we're good to go, and let's run the code again. Now I have the habit tracker. I'm going to create a habit. I'm going to call it workout. I'm going to say I have to work out every other day. And yeah, problem solved. Habit created with ID 1, and I got my habit tracker list again. So let's create another habit. I'm going to call it learn a new skill. It's going to be a habit of mine, and I have to learn a new. I have to work on learning new skill every weekend. Great, I have 2 habits, so let's list the habits with choice 2. And I have 2 habits: workout streak 0, learn a new skill streak 0. What if I want to increment a streak? So I'm going to add 3. The habit ID, say I worked out today, so the first one. So the habit updated to 1. Now let's list the habits again. See that my workout got a streak of 1. And now it's time for deleting a habit. We incremented streak, we created habit, and we listed habits. So let's delete one of them. The habit ID we're going to delete is 1, the workout one. And habits got deleted, and I'm going to list them again after deletion. So I only have the habit with ID 2 now that I know I have deleted the first one, and it's learning a new skill streak is 0 because I haven't done it yet. And for exiting, I just have to enter 5. Bye! Now that we're done with our coding, it's time to talk about a few decisions we made while making our project. So the first one is that we have a layered architecture here in our code. We split the project into well-defined layers like UI, service, repository, model. This separation follows the separation of concerns principle, which keeps the system modular and maintainable. The UI layer handles user input and display, the service layer enforces business logic, and the repository layer manages data persistence, and finally the model layer defines core data structures. If you decide to replace the console with a web UI or move from in-memory to database persistence, you only change a single layer without touching others. This makes the project scalable and adaptable. The second choice we made was having an immutable model, the habit class. We made the habit model immutable, final fields, no setters, and with a strict method for updates because immutability brings thread safety, predictability, and fewer bugs in state management. Once a habit is created, its internal state cannot change unexpectedly. Instead, with a strict method returns a new object with a modified strict value, making behavior explicit. This mirrors best practices used in functional programming and modern frameworks like record-based DTOs in newer Java versions. The third choice we made was using DTO, or the habit create request. We introduced a DTO to capture input data from the user before creating a habit. Why we did that? Because a data transfer object or DTO separates external input from internal domain models. If the input format changes, for example, extra fields like goal days, you only have to modify the DTO, not the model. It provides validation safety. The app never directly exposes domain objects for write operations. This pattern also helps when scaling toward an API layer design. And the next one is repository pattern. We used repository pattern with interface and implementation. We use habit repository as an interface and in-memory habit repository as its implementation. Why? Because the repository pattern abstracts persistence layers. It allows swapping storage implementations without affecting business logic. Currently, in-memory habit repository stores data in a map. Later, you can replace it with a database habit repository that uses an SQL or NoSQL database, all without changing the service logic. This promotes dependency inversion, the D in solid. The service depends on abstraction, not concrete implementations. Now let's talk about the service layer. The service layer or habit service isolates logic like creation, strict updates, and validation into a service class. Why? Because the service consolidates business logic that would otherwise pollute the UI or repository layers. By keeping a state management like strict increments or habits lookups in habit service, the app avoids redundant logic across layers. This design makes it easier to test and reason about use cases independently. And finally, let's talk about my favorite part, the console UI. The console UI creates a simple text-based interactive interface. A console interface keeps user interaction simple, focusing on logic, not presentation. It demonstrates the architecture clearly while remaining replaceable. Because UI logic communicates only through the service layer, it could later become a graphical interface or REST API without modifying the service or repository code. And let's talk about our entry point, which is the app itself. The app assembles the system and runs the console in app.main method. Keeping dependency set up in the entry point instead of scattering it through the code centralizes object creation and wiring. This choice mimics the structure of dependency injection frameworks like a Spring, but without complexity, perfect for beginners. The app class acts as the composition root, the single place where class dependencies are constructed and passed down. And next, we have simplicity over frameworks. We avoided Spring, Hibernate, or other heavy frameworks. Why? Because frameworks can obscure underlying principles. This project serves as a teaching foundation, showing how to structure clean, testable code without relying on automatic configurations these frameworks offer. Once mastered, these patterns transfer directly to larger enterprise-grade frameworks. Our code here is solid and clean. Why? Because we have the S in single responsibility, which says each class does one thing. Second, we have the open-close principles. Our components can be extended. For example, we can have a new repository type without changing existing code. We have list of substitution, meaning any class implementing habit repository can replace another transparently. And we have interface segregation. The repository exposes precisely what's needed, no bloated contracts. And the last one, dependency inversion. High-level modules like service depend on abstractions, not concrete implementations. We applied this principle because they result in predictable, maintainable, and refactor-friendly software. And we also avoided static methods and tight coupling. Why? Because every class depends on interfaces or objects that can be mocked in tests. With this setup, unit tests can verify service and repository behavior independently. It is critical for scaling projects or introducing continuous integration. I really hope you guys enjoyed this project we built together. The goal of this new series of videos is to help you get comfortable with coding. They'll guide you when you're starting out, give you a sense of what's going on, and show that coding isn't as scary as it seems. Later on, once you feel more confident, you'll be able to come up with your own projects and build things from scratch. For now, if you want to revisit some core Java topics like the final keyword, you can check out the videos in my beginner's Java course linked in the description. You can also find the code for this project on my GitHub repository. The link is below as well. If you have any questions, drop them in the comments and don't forget to like and subscribe.